Dear students, you are welcome in the Education Department at SHAHD Association. Our lesson today is forces. Make sure to subscribe to our channel for more lessons and don't forget to activate the bell to stay notified.
Today, we have two objectives. We will read the magnitude of a force by a spring balance. We will draw a force on scale. We saw in the Explore section the difference between the two forces that the two boys make on the box. Today, our lesson about representing forces. But before we start, let's take about the spring balance. A spring balance consists of a spring with a hook at the bottom that can be pulled down. This instrument is used to measure the magnitude of a force. This is the picture of a spring balance. This is the spring, and this is the hook. We have many types of spring balance. The first one is called the digital spring balance, which gives a number when the load is attached to the hook. The second one is called the needle spring balance, where the needle moves when the load is attached. The final one is called the graduated spring balance, which points a number when the load is attached to the hook. If the hook is not pulled, this means that we didn't apply a force on the spring balance, then the pointer of the spring balance remains at 0. This is the first case. The second case, when the hook is pulled down, the pointer of the spring balance moves from 0 to a value. The reading of the spring balance is the magnitude of this force. So if we take an example to the right, when the man pulls the hook of the spring balance, the pointer moves from 0 to 7.5. Then we say that the magnitude of this force is 7.5 newtons. We will now move to the force vector. A force vector is a representation of a force that has both magnitude and direction. We use an arrow to represent the direction, like in this example, which is to the right. The length of this vector is the magnitude or the amount of the force. Let's take some cases of force vector. The first case, this force is acting to the right and horizontally with magnitude F is equal to 20 newtons. The second case, this force is acting horizontally to the left with a magnitude of 10 newtons. The final case, this force is acting upward and vertically with magnitude 10 newtons. To represent a force vector, you must choose a suitable scale. For example, a force of magnitude 5 Newton that is horizontal to the right. The first thing to draw this force vector is that we have to choose a scale. For 1 centimeter, there is 1 Newton. Write this scale to the right. So for 5 newtons, how much the length of the force vector be? Instead, put it x. Now do the math. So if we want to find x, we have to cross multiply. So 5 Newton times 1 centimeter divided by 1 Newton, it will give 5 centimeter. We put a ruler. We draw 5 centimeter vector to the right, like this. This is the force vector that is 5 Newton magnitude and horizontal to the right. If the force is bigger, you must choose a bigger scale. For example, if we have a force of magnitude 20 newtons that's horizontal to the right. The first thing, you have to choose the scale. Suppose that we choose a scale of 1 centimeter, it gives 5 in Newton. Put this scale to the right. Now for the 20 newtons, how much the length of the force vector be? Put it x. And let's do the math. So x will be equal to 20 newtons times 1 centimeter divided by 5 newtons. It will give 4 centimeter. We put the ruler. We draw a vector of length 4 centimeter horizontal to the right like this. This is the force vector of 20 newtons. This is the end of our session today. If you have any questions on the worksheet, please don't hesitate to contact me.
Thanks for watching. If you like this lesson, make sure to subscribe to our channel for more, and don't forget to click the bell to get all updates.